Picking up right where we left off with the DHCP snooping lab, which we've completed. And, you might get a little depressed because you just wonder, if I can't trust DHCP, for God's sakes, who can I trust in this world? Well, I don't really know the answer to that, but I'll tell you one thing. It's not the address resolution protocol either. It can turn on us. And it's not really turning on us as much as being used for evil instead of good. But one way or the other, you and I as the network admins are getting the wrong end of the stick when something called ARP cache poisoning or ARP spoofing occurs. And that happens when a rogue device on the network overhears part of the ARP conversation and then makes itself look like a legitimate part of the action. And in this diagram, host A is sending an ARP request requesting that the host with IP address 172.12.12.2 respond with its MAC address. All good and innocent. So here's the message going out, and before responding, host B is going to make an entry in its local ARP cache saying, okay, I got this message in, an ARP message. The source IP is 172.12.12.1. The MAC address is all A's, and I will put that in my cache. Then the reply is sent. Well, at that point, once host A gets the ARP reply, both hosts have a MAC address to IP address mapping for the other. But if we have a rogue host responding to that original ARP request, then we have a problem because something like this is going to end up happening. This is what we call a man-in-the-middle attack. And again, it's a pretty intuitive name because what's happening is the intruder is inserting itself in the middle of a legitimate conversation, which is going to turn non-legitimate very, very soon. As a result of this, and you can see what's happening, the rogue host is sending an ARP reply saying, hey, I'm 172.12.12.2 and my MAC address is all C's. Well, host A makes an entry in its ARP cache with that mapping, and meanwhile, the rogue host in another process, not shown, acquires host B's true MAC address via ARP, leading to two negative results. The first one is that when host A transmits data to 172.12.12.2, the corresponding MAC is going to be the rogue host's MAC address, and that's who's going to get it. Second, the rogue host reads the data and can then forward it to host B, and it happens so fast and so transparently that neither A nor B notices anything really wrong. And the rogue host can do the same for an ARP request sent by host B for host A, and at that point it's a true man-in-the-middle attack. The rogue host is really the hub, if you will, of communications between A and B. It's almost like hub and spoke. Anything A sends to B, it's got to go through the rogue host. Anything B sends to A, it's got to go through the rogue host. We need to do something about this, and what we're going to do is dynamic ARP inspection, DAI. Now, it's going to prevent this behavior by building a database of trusted IP to MAC address mappings. And this database is the same one built by the DHCP snooping process, and also static ARP configurations can be used by DAI. So again, I know I mentioned in the previous video, and it's the first thing we're going to check here, you've got to have DHCP snooping in order for DAI to operate correctly. You really want to watch this one though, especially on your exam, because DAI does use the concepts of trusted and untrusted ports, just like DHCP snooping does. But there are some major differences in how messages are treated by those port types. Also, one more thing I want to mention to you, DAI is performed as ARP messages are received, not as they're sent. That's really important to watch. Now, once that IP to MAC address database is built, every single ARP request and ARP reply that's received on an untrusted interface is going to be examined. And if the ARP message has an approved MAC to IP address mapping, pass friend, everything is good. If no such mapping exists, as we would expect, the ARP message is dropped. On trusted interfaces, DAI lets that ARP message go through with no check at all. So when you're trusting with DAI, you are really, really trusting with DAI. Now, let's go ahead and check that database, and then we'll run through a couple of commands. And let's get our lab equipment up here. And we've already got show IP DHCP snooping right up on the board. That would be the first thing I run before starting a DAI config. And all I need to see is switch DHCP snooping is enabled. Now let's look at the ARP inspection specific commands. Got a couple of them here, but the one we're really interested in right now is VLAN. And we are enabling, disabling ARP inspection on VLANs. Of course, we are going to enable it here. And we'll just stick with VLAN 1 like we did with snooping. And one more option I want to show you here, and that's for validate. That's what I wanted to show you. We have a dist MAC, an IP, and a source MAC. And what that means, of course, is destination MAC, IP, and source MAC. And we're validating that particular address. If we choose the source MAC option, what we're comparing is the source MAC address in the Ethernet header and the MAC address of the source of the ARP message. Destination MAC, we're comparing the destination MAC in the Ethernet header and the MAC destination address of the ARP message. IP, of course, compares the ARP request source IP against the destination IP of the ARP reply. So let's go ahead and use the IP option here. And you can see we could actually do some more validations, but I think that IP is going to be good enough, and we're not going to have any exceptions, so we don't need allow. So let's just go ahead and put the IP option in, and to validate, or excuse me, to check your configuration and to validate your configuration, show IP ARP inspection will get that done. A lot of things here we're not using and we're not going to use in this particular lab, but you can see that it is enabled for VLAN 1 and it's active. You can also see your source MAC validation, destination MAC validation, and IP address validation settings are at the very top of the output. I know I've got a little bit of that command cut off. There we go. And source MAC, destination MAC are both disabled. That is the default. All three are disabled by default. They have to be explicitly enabled if you want them. One thing I would warn you about here that I've bumped into, if you see these validation failures start to accumulate, then you need to look around because something's causing that. Duh. But you need to go find out what is causing that. It's not enough to just know, hey, something's causing that. We need to go out as network admins and find out what that something is. Now, DAI considers all of our ports to be untrusted by default. And again, there are big differences in the trusted, untrusted concepts between DAI and DHCP snooping, so be sure you're clear on what happens with each one. Let's just say, though, that we wanted to trust Fast Ethernet 0/2. We don't want any inspection on there at all. We would just do fast02. The command is IP ARP inspection. And we've got a limit where you can configure the rate limit of incoming ARP packets, but what we're really interested in is trust, and that is it. Now, if I wanted to do a verification of that, you can do show IP ARP inspection. And that's going to show you, sorry, I meant show IP ARP inspection, and then put the interface here on the end of it. Is in enough? Yes, it is. So that's a way to check out an individual interface, and you can see that interface 0/2 is trusted, and the rate PPS, we haven't set a limit, we're not going to. Burst interval, we're not really concerned with right now. So that does it for ARP inspection. A couple of very straightforward commands, a couple of options to know. You got to have DHCP snooping involved. I'm not going to mention that again until the next video. And speaking of that very next video, we're going to talk about and see in action IP source guard. And I have a pretty good idea what we're guarding, but there are probably some options there we need to know about as well. So I'll see you in the next video. We'll run through that.